Hi, my name is Juliana Crever, and my chosen project for the science fair was the effect of cream on coffee's rate of cooling. So, when I was deciding on my idea, I realized that I drink coffee pretty much every day, and I'm always curious to know what I can do to improve the quality of my coffee. And I also remember hearing that someone asked the question of whether it made more sense to add cream to their coffee earlier or later in order to preserve the most heat. I also have an interest in physics and especially thermodynamics, so Newton's law of cooling is something that I've always found very interesting. So, all of this together led me to create this question. When adding creamer to coffee at different times, the coffee reaches lower temperatures at different times as well. What is the relationship here? How does the time of creamer added to coffee affect its rate of cooling? Or when is the best time to add creamer to coffee in order to preserve heat? So, I gathered my research. The law of cooling was developed by Isaac Newton in 1701, and it states that the rate of heat loss of a body, in this case my coffee, is directly proportional to the difference in the temperatures between the body and its surroundings. So here is the formula for the law of cooling, where T of T is temperature at a given time, T of S is the temperature of the surroundings, T of 0 is the starting temperature, and K is our rate of cooling, which is what we will be solving for in this case. Two other important things to remember are the first and second law of thermodynamics. The first states that energy in a reaction can change form, but it cannot be destroyed or created, similar to the conservation of matter. The second law is that entropy has the tendency to increase in pretty much all cases, and entropy is randomness, meaning the movement of molecules and the movement of energy will become more random over time rather than less random. So here are two pictures that show the temperatures that I would be using in my law of cooling. The first one is the temperature of my surroundings, which would be T of S. And then this was taken actually during the cooling period, so this wasn't one of the temperatures that I used for my formula, but this would either be my T of T or my T of 0, which is about 145.9 degrees Fahrenheit. So here was the actual design for my experiment. Based on my research, I developed the hypothesis that the cup of coffee to which creamer was added later will have a faster rate of cooling than the cup which immediately received creamer. So my materials were about 3 coffee mugs, thermometer, a stir so I could stir my coffee, measuring spoons, and of course, my coffee and creamer. So my procedure was to brew a cup of coffee, add cream at the designated time, wait for what remains, oh, and take the temperature at the designated time. Wait for what remains of the 10-minute period, then record the temperature again. And then I would repeat this for 2 more trials. So for my first trial, I added creamer immediately. For the second trial, I added it after 5 minutes. And for my third trial, I added it after 8 minutes. So here you can see where I conducted my experiment. Those are my materials on the left, and then this is me brewing the coffee and adding the cream. And here's my resulting data. So for the first trial, after adding cream, it was 150 degrees Fahrenheit, and then after the remaining 10 minutes, it was 134 degrees Fahrenheit. For my second trial, the temperature started at 141 degrees when I added the cream about 5 minutes in, and then by the end of the remaining 5 minutes, that was 135 degrees Fahrenheit. And then in my final trial, after 8 minutes when I added the creamer, it was 141 degrees Fahrenheit. And then after the remaining 2 minutes, it was 136 degrees Fahrenheit. And there you can see my calculated rates of cooling. And here's a graph which better illustrates my data. So my conclusion. Interestingly, while my overall hypothesis was supported that the coffee which received the creamer the fastest had a lower rate of cooling than the coffee which received it later, my data did not fit my overall expected trend. And while I didn't mention this in my hypothesis, I expected the rate of cooling of the second trial to fall between the rates of the other two. But in fact, this was not the case. The rate of cooling was actually the slowest of the 3 trials. So I think this was definitely attributed to human error, which leads me into my second point, which is that my sample size was very small. Human error is a problem that can happen. And another interesting effect here could have been the size, shape, color, and possibly material of the mugs I chose, which can affect the rate at which heat is removed or, moves back and forth between the body and its vessel. So, overall, my conclusion was that when making a cup of coffee, adding cream earlier will allow it to retain more heat for a longer period of time than adding the cream later. If I were to repeat this experiment, I would likely find similar results, but I would definitely try to avoid any error here involving mugs, sample size, or of course, human error. Overall, I had a really fun time doing this experiment and I'm very pleased with my results. Thank you for watching.